since I didn't say most of those words while the recording was on, the most important thing that I just said was that the test is on Thursday. We have one more day of lessons, and then we have a test. Yay, everybody's favorite. Everybody's. Nobody lies. All right. What? All right. Page, whatever it is, 60, no, 60, 61 and 62, and we did what, 12 through 32? That's what I was going to say. All right. Okay, 12 through 32. For some reason, past me wrote 10 through 32 evens, which doesn't even make sense. Maybe I really wanted them to do that perimeter problem. Or maybe I did it, wrote it down wrong. I don't know why I started writing down these things. Whatever. Nobody knows. All right, here we go. Number 12 is a heptagon. It is concave and it is irregular.
Is irregular fine?
No, irregular is not a word. Irregular is a word.
How do you spell irregular?
Irregular. Irregular. Number 14 is a quadrilateral. It's convex and it's irregular. Number 16 is a pentagon. It's convex and regular, and apparently causing my voice to crack for some reason. Good job, pentagon. Number 18, perimeter or the circumference is about 25.1 inches.
We don't put the second.
What?
Not two.
Yeah, the other one is. No, it says in the instructions around the nearest tenth. So, the area is about 50.3 inches squared. Number 20, the perimeter is 33 feet, and the area is 20 feet squared. 22, the perimeter was about 36.5 centimeters. Excuse me. And the area was 105.7 centimeters squared. Number 24 was about 9.42 feet. Number 26 will require the television. So let me get my phone and take a picture so you can see the picture. We'll even move the camera around so they can see the picture. Did that do anything? Nothing happened. There it goes. Whoa. Okay, so there is 26. There's the picture, and the perimeter formula would be right there. You,
61, but where did you get the 11?
well, we'll do that when we take questions here in a second. Number 28 is right there. It looks like to me that for 26 and 28, you would have to use the Pythagorean theorem to get the answer. Leave that up there. Swivel this back around, and then we will do the rest. Number 30, right? 30A is 60 meters. 30B is 150 meters squared. 30C is the perimeter doubles and the area quadruples. Perimeter of a triangle with side lengths 30 meters, 30 meters, 40 meters, and 50 meters is 120 meters, which is twice the perimeter of the original figure. Because 2 times 60, that's 120. The area with the base 50 and height 24 is 600 meters squared, which is 4 times the area of the original figure. So it's 4 times 150 is 600 meters squared. 30D, the perimeter is divided by 3 and the area is divided by 9. You give a similar explanation. We can go over those if we need to. And number 32 is 5 feet and 70 feet. So, what questions do we have on that homework set?
Can we do 18, the area?
We can do 18, the area. Eighteen is a circle. Centimeters or something, whatever it is. Inches. Close enough. Okay. What's the formula for the area of a circle?
Pi times radius squared.
Pi r squared. What's the radius of our circle?
4.
It's 4 inches. The whole thing is the diameter. So it gives you the whole thing, and it's the diameter. You got to do half of that to get the radius.
Oh, that's why I got
Yeah, I knew it, but it was easier to show it. Yeah. Okay. Right. Okay, so yeah, you do pi times 4 squared, which will be pi times 16, which would be something, like 50 something, right?
How did you get on 22 the perimeter? What was the answer?
On 22 for the perimeter, what was the answer? Is that what you said? Okay. Excuse me. On 22, the perimeter was 36.5 centimeters.
How'd you get 5, 2, and 4 on height again?
What are you saying?
Because it says round, but 2 and 4 won't.
Let me punch it in and see what I get and see whether I agree with you or the book. So 2 times pi, I gotta remember where the pi button is, right there, times the radius of 5.8, which is 36.442. So yeah, 36.4 would be a better answer. I agree with that statement.
Did you have to put units?
Yeah. What other questions from this homework set?
Could we do 28?
We could do 28. Did y'all figure out whatever y'all are figuring out over there?
My calculator wouldn't use pi's probably. It would use just the symbol.
Oh yeah, did you figure out how to switch it? Good. Yeah, so most of your calculators, not necessarily all of them, but most of the calculators in here, the default mode is math print, and it's going to give you the most exact answer possible. So you got to switch back and forth. You can, if I use this calculator for grading, you can switch it to where that's not the mode, and it'll give you the decimal first, and you have to do it you have to push the buttons to go the other way around. So all that stuff. Most of y'all don't really care. You're like, okay, tell me how to get what I need to get. I don't care. But, there it is. I like math print. It's good because it gives you good answers that are clean and reduced and whatever else. 28. All right, here we go. Heaven help us. It is worth noting that I will likely, I might give you a problem like this where you have to, that's funny. We need some resistors. I might give you a problem like this where you had to do algebra with a coordinate thing or whatever else on a test. It's unlikely, and I will never. This is gonna apply next unit. I will never give you a coordinate proof on a test, and I will never intentionally assign you a coordinate proof for homework. So if you ever get to a homework problem and it says, do a coordinate proof for this, you can omit that problem. And if you're scared to omit that problem, you can always message and be like, this is a coordinate proof. You said we don't do those. Can we omit it? And I'll be like, yes. So it's worth saying that now. Because what's likely to happen, if you forget that, is you'll do the coordinate proof, you'll cry about it, and you'll be like, I don't know how to do it. And then you'll ask, can you help me? And then I'll be like, no, we omit those. And you'll be like, dang it, I wasted all that emotional energy on nothing. So skip those then. But this one will do, because this is a useful problem. All right, here we go. 28 is the one we're doing?
Yeah.
So -2, 3. Of course you picked the one with the most points. Good job. These are good problems, which is why we're gonna go ahead and do one. They're good problems because they get a lot of skills in one thing, and they're really tedious. So, all that's true.
Something very bad happened to my rectangle.
Something very bad happened to your rectangle. It sounds ominous.
It got beaten up.
It got beaten up. 5, 2, 2, 3, 4, 5.
Like the tick mark's too big and then it like.
These are definitely easier on graph paper too. You wrote the tick marks too big and then it turned into a kite.
Yeah.
2, -1. All right, close enough for government work. If it was on grid paper, it would probably be much better, but I don't have grid paper whiteboard. One of these days, I need to get one of those little portable projector things, and I can pop up a graph on there. Surely those aren't super expensive anymore. Haven't looked in a long time. All right, there's the graph. Now, what are we supposed to do with it? Graph it, done, check, did it. Identify the figure. It's a, so, so you might be tempted to say, it's a rectangle, because obviously it's a rectangle. You can't say that. Because how do you know it's a rectangle? What things have to be true? Yeah, this is geometry. That ain't gonna fly. This isn't art class. This isn't even woodworking class, where if it looks good enough, it's good enough.
It has a short angle and another short angle.
It has a short side and a long side. It has nothing to do with a rectangle. A square is a rectangle. They have all 4 sides the same.
It has to have
Has to have right
right angles.
angles. First correct answer so far. It has to have all right angles. Yeah, it has to be a quadrilateral. Yeah, that's true. So it has to have 4 sides. 2 pairs of parallel lines. That's true. And one more thing that we haven't said that's going to be important for us to be able to prove this. Because y'all don't know how to prove things are parallel yet. So that's true, but only so helpful. And that could also be a parallelogram. A parallelogram. One more thing that's important with a rectangle.
Two sides are congruent.
That's true. That's true. Opposite sides are congruent. So, in order to classify this triangle, we have to figure out, are these things perpendicular, and are these things and these things the same size? So how do we figure out if a line segment, let me ask it a different way. How do we decide how long a line segment is on a coordinate grid? We have a handy dandy way of doing that. Distance formula. I should probably label those points so I don't have to go back and forth to the book.
Rectangle.
It is certainly a rectangle. It's like when we do this, we're going to be like, it's a rectangle. It's almost certainly. Although we might prove it's not, and then we're just like, oh, well, we're up a creek, it's just a quadrilateral.
Now, why were you saying all that if it's a rectangle? Because it looks like one.
I'm going to punch you in the face. You got it. There's, geometry does that. Just so we're clear, internet people, I would never punch a student in the face. Or would it? No. So there's always that student in geometry. Always. When we get to proofs, just so we're clear, the answer is never because it looks like it or obviously. Neither one of those are correct answers on a proof. You have to give more details than that. All right, distance formula. So I was going to label the point so I don't have to keep going back and forth. This is negative 2, 3. And it's t. And u is the one that's 1, 6. So this is 1, 6, and it's u. And v is at 5, 2. 5, 2. And this is v. And w is at 2, negative 1. 2, negative 1. So here we go. So let's find the distance between TU. We're going to assume, for the sake of expediency, that you remember the distance formula. Hopefully it's in your notes. Hopefully you know what's happening. If not, send up a flare and we'll make sure you get answers to your burning questions.
Does it matter which one you have as x1 versus x2?
It does not, as long as you're consistent. So like if this is 0.1, then this is both x1 and y1. So you can't pull x1 and then y1 from over here. So it doesn't matter which one's 1 and which one's 2. Okay. All right, what's going to go right here?
Negative 2.
Negative 2. What's going to go right here?
1.
And then here?
3, 3.
And here? 6. Okay. So d equals the square root of negative 2 minus 1 is?
Negative 3.
And then negative 3 minus 6 is what? Negative 3. Yep.
3's negative though?
Which 3?
You said negative 3 minus
Oh.
6.
I did say that, but I did not mean that.
Oh, okay.
Yes. Yeah, it's positive 3. I just said wrong words. Yes. So negative 3 squared is what? Is positive 9, because negative times the negative is positive, right? Because the negative is squared as well. So, and then 9 plus 9 is 18. And I'm just going to leave that. Like, I don't even care about reducing it. We're just trying to figure out whether this is the same as that. That's all I care about, right? So, there's actually, later when we learn theorems about rectangles, we could shortcut what we're doing a little. And we could find like 2 things. And be like, yeah, it's a rectangle. But y'all don't know that yet. So we got to go the long way, right? So find the distance. This is between TU. And so now let's find the distance between WB. And if they're the same, then that's great. We've gotten one step closer to figuring out it's a rectangle. Square root of what's going to go here?
2.
And here?
5.
What about this one?
Negative 1.
And this one?
2.
2. Great. Y'all don't have to sound so excited. You can calm down a little. Square root of negative 2 minus, excuse me, I did it again. 2 minus 5 is? Negative 3 squared. Negative 1 minus 2 is? Negative 3. All right, I don't even have to go any further. This one matches this one. Great. So those sides are congruent. That's useful. And for the sake of expediency, I'm going to kind of give you a shortcut for later. If I just find that one of these is a right angle now, then it's a parallelogram. It's great. They got two sides that are congruent. I get to throw a right angle in there. It's a rectangle. Great. Now, that was easy to remember because we've reviewed it so far. We've already reviewed it this year. The next one is less easy. We need to figure out how to tell whether these are a right angle.
He draws.
With algebra, not with not with a protractor or something like that, just so we're clear. How can we find out if two lines, so if two lines make a right angle, we have a special name for those lines. What are they called if they make a right angle, if they cross at a right angle?
Perpendicular.
They're perpendicular. Okay, so what we got to remember is we got to remember how to tell if two lines are perpendicular to each other. So how do we do that? So let me kind of walk you there a little bit. And I'm walking you there so we get more pieces. Because none of this is going away, and you're going to have to use all of it at some point, and definitely after this class, and some in this class. What is that? What did I just write? Don't just read it to me. What is it? It's the slope-intercept form of a line. That's right. So two of those letters are informative. They tell us something about the line. Which two tell us something? The B is the y-intercept, so that's one of the two. What's the other one that tells us something? The M is the slope. So those two tell us something. So one of those two things, so wait, actually I should go back even further. I should go even slower a little bit, right? And I'm going slow on this topic in particular because y'all know like public schoolers have to take an end of the year test, right? They have to take, right now it's called STAR, before that it was TAKS, before that it was TOS. So, it'll be something else in a year or two or whatever else because Peterson has to make their money somehow, right? But, yep, said it, internet. It's on there for the two people that watch this video, right? Okay, so what am I saying? They have to take an end-of-year test. If you, as a public schooler, like hardcore dive into linear functions and nothing else, you can pass that test. Because it's that big of a chunk. And there's a reason. It's because there are so many linear relationships like in real life and in future math and whatever else. So this is a super important topic. This is something you have to understand. Not today necessarily, but throughout the course of your math life, you need to understand this. This is important. So that's why I'm slowing a lot down. So the B is the y-intercept. That is a fact. What does that mean? What is a y-intercept? Yeah, so where our line crosses the y. So like this one has a y-intercept right here. This one has one right there. This one, if we continued it into a line, would have one down there. This one, if we continued the line, it would have one up there, right? So that would be the B part, right? What is the M? We said the M is the slope. What is the slope? What does that mean? Yeah, it's how slanted it is, right? We use rise over run, how much it goes up and how much it goes over, or how much it goes down and how much it goes over to figure out what that is. And so it's a number value that tells us how steep the thing is, right? That's what's going on. So now, bringing that back to this problem, one of these two pieces of information can help us determine whether two lines are perpendicular. Which one do you think it is? That's good. You got a 50-50 chance of guessing right, and you did good. Good job. Virtual high five. Bam. Oh, you were too slow. Hit you in the face. Sorry. Yes, we can use the slope. So lines that are perpendicular, they have a particular kind of relationship with their slope. So parallel, now it's easier to think about it with parallel lines, right? Parallel lines, if lines are parallel, what's true about their slopes? They're the same. That's easy, right? No big deal, right? What did you say? Their slopes are lines. No, their slopes are fractions.
No, I said they're lines.
Yeah, and I asked what's true about their slope, and you said they're lines. So you said their slopes are lines, which is false. They're fractions. They're scalars. Okay. Excuse me. Lines are vectors-ish, kind of, sort of. But We're not caring about that right now. It's different math. So that's easy. That has the same. What about perpendicular lines? What's true about their slopes? Okay, so they're opposite, which means one is positive and one is negative. So that's one piece of it. So they're opposite and one other thing.
They're crossing lines.
That's true. I'm still asking about slopes though. Opposite reciprocal. So to find the slope of a perpendicular line, you flip the sign and you flip it over. We flip the sign and we flip it over, right? So if we can figure out that these lines have opposite reciprocal slopes, we're going to be home free. We're going to have solved this problem and we're going to be able to do our quiz and it's going to be great. So we got 2 points. How do we find the slope between 2 points?
We use the equation.
Yeah, what is the equation for slope?
y1 minus y2 over x1 minus x2.
So close. Except it is. Why am I talking? I wrote M and got midpoint and I thought midpoint. And you are exactly right. Good job. Virtual high five. Oh, a little slower, still hit you in the face. It's okay. It's okay, you got the video. You'll be fine. All right, so the slope is the difference of the y's over the difference of the x's. It is y rise over run. Right? So we need to find the slope between TW. So we need to find the M between TW. What's going to go right here?
3.
Sure. What's going to go right there?
Negative 1.
And here?
Negative
You don't have to sound so excited. Calm down. Here?
2.
Wow. That was a little more exciting. All right, what do we got to do here? We got to ka-chink those. What's 3 plus 1?
4.
It's 4. Negative 2 minus 2 is what?
Negative 4.
Negative 4. What does this reduce to?
Negative 1.
Negative 1. So if this is perpendicular, if it has a right angle, then this one will be positive 1, because negative 1 over negative 1, negative 1 over 1 is still negative 1. So opposite reciprocal of negative 1. We take negative 1, we flip the sign and turn it into positive 1, and we've got 1 over 1, which is 1, right? So we're looking for 1 over 1, which is 1, right? On these two. So we need to find the slope between those two. So the slope between WV. What's going to go right here?
2.
And here?
Negative 1.
And here?
5.
It's that one where we just like all the energy drops out of the room. I don't know. Something about this little spot there. X, something about X2. Okay, right here. 2 plus 1 is 3. 5 minus 2 is 3. This gives us 1. Therefore, that's a rectangle.
Whoa. You like what I said in the first place?
I told you that it was almost certainly true. I didn't tell you you were necessarily wrong.
Yeah, but you were like, you can't just say
But if you would have said on the lesson, if you would have said on the lesson that it's a rectangle because obvious, you would have lose a lot of points. Oh, look at you. Ah, I see. You were that's fine. Sure, why not? Predictive.
So I don't know if I did any of the math right.
To me, it was a 28.
28.
Oh.
This is 28.
Can we do
Yeah.
20?
I kind of did it backwards when it comes to the
We didn't really find the perimeter. You'd have to find since we know it's a rectangle now, you just, add up the things that we already found. I guess you'd have to find the distance of these short ones, at least one of them.
So there was also one where it was asking me with 26, there was a triangle. And
Yep.
It was like, I didn't understand it because we've done the square and like the formulas to go through, but I didn't understand because they would be different for a triangle and a rectangle.
What's the formula for area of a triangle? The test is on Thursday.
I got the.
Base,
Times height divided by 2.
great. So shove the numbers in and Bob's your uncle.
Like,
Which number?
and that just works it.
So the triangle has a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4, 5. Great. So there, yeah, that just works it for the. And then for the perimeter, you got to use the distance formula to find the distance between J and K, but then add all those up together.
Okay. So the distance formula is, yeah.
Yep, it is.
Square root
Could
of.
you probably?
Yep,
20?
square root of all that stuff. That's right. That is what it is. It is what it is. 20. Yeah, great. Yeah, 20's a little bit weird. It's easy, but it's a little bit weird.
I got the perimeter and I divided it by 4, so I said it's a rectangle because all the sides are even.
Because all the time, what? Well, at least you were trying to logic your way there. Don't, and that's for this. This might be good advice for a few of you. This is a rare issue on proofs, which we're going to start in the next chapter. But it is an issue that crops up from time to time for students that are either clever or think they are, one of the two. Don't try to make up your own theorems. Use only the theorems that are, you already know. Don't try to make something up new. If you do, that's fine. It's not going to ruin your life, but you probably won't get any points. Don't try to make up a new theorem. You don't know enough math to make up your own theorems yet. Okay, what are we doing? 22, 20? Okay, great. We got this weird looking triangle that is getting tired, leaning over, about to die. And we got all these descriptive bits. Got an altitude drawn on there. We'll talk more about that later. We got 16 feet. We got 5 feet. We've got 12 feet, which is somewhere. I assume it's this side is what it's talking about. From the picture, y'all's is probably more spread out, so y'all's is probably more clear. So if y'all's look like it's something else, then let me know. We probably don't even care. What did you said the area or the perimeter? What did you say?
I just said both of them.
Okay. So how do I find the perimeter of this shape?
You add all the sides?
Yeah, so which numbers would I add?
16, 12, and 5.
16, 12, and 5, because those are the sides that are the same. The 8 doesn't have anything to do with the perimeter. And the 12 doesn't have anything to do with the area. Right? That making sense so far? Is that a mistake you made probably?
The 8, the height?
The 8 is the height.
Yeah, that's height.
Yeah. So to find the area, you do 5 times 8 divided by 2. So the answer is 20, right? What?
Really?
Really?
I didn't do the area part because I was confused because
Well, the base of the triangle is 5, and the height of the triangle is 8.
I thought that only applied if the 8 was actually one of the sides.
Nope, it applies no matter what. It doesn't have to be just a right triangle. Yeah. Yeah. That's a understandable confusion. Glad we could clear it up for you.
So,
Is my phone telling me anything that I need to care about? Like students? Probably not. Clearly not. Oh well, what are those hidden things? Continue, go ahead.
how would you finish 28? Because we figured out it was a rectangle, but how do you get that number?
So you'll find excuse me, through finding this rectangle, you'll find the distance between all the sides, and then you just add those up for the perimeter or multiply the two sides to get the area. Yeah.
You have to get the
Decimal,
no,
square root.
yeah.
Yeah, you have to punch it on your calculator and push enter and then get a decimal equivalent and yeah.
Okay,
Yeah.
but I don't know. And that's the answer?
Yep. Yep.
For area and perimeter?
Well, for area, you'd multiply the two sides together, right? This side times this side. And then for perimeter, you'd add all 4 sides up. Yeah.
Then
Yep.
you get the square root from.
The distance formula.
Right, but so each side
Right. Once you've proved that it's a rectangle, then you really only need 2 sides. True enough. What other questions from this lesson? None? Okay, good. Let's take a quiz. So at least this will be like what, our second quiz, right, for this unit?
Yes,
All right, now we have at least 2. So if you bombed the first, this is quiz 1-2. And we're going to do from page 62. And we're going to do numbers 17 and annoying. I don't want to do a rectangle and a rectangle. So let's also, so yeah, do 62, number 17, and page 61, number, whatever that was, 7. 7 and 17. All right, ready to go. Go forth and prosper.
So you just have to cut it in half
To get the radius, yes. That's correct. Once you have taken your quiz and given me your quiz, you are free to leave.